Okay, so we're talking about this how to uh, just to click on this. Once you finish this uh, design and the simulation, just to click on this, you go to the home screen. So it takes a little bit amount of time because it works very slow because it will be working online. You can see. So here all the circuits what you have designed will be available, and recently used circuit will be the first and the others next. Now here, this is the other circuit. This is a half done. Say if you already done, it looks like this, and you have to go for the tinker this. Click on this. So as I said, it works very slow online. Yeah. So this is some random name will be there. Just I'll give a case KVL or KCL, anything we can do. Let's do KCL first. KCL. Okay. Say you can see now just 3 multimeters I have used here and 1 power supply. Just I was about to wire these. Okay. Let's change the color of this wire as the red because it is a positive. Okay, and let's connect this. And let's use the one more wire from here itself. Okay. And let's connect 1 millimeter. Should be positive as we know. And this one should be connected to. So I'll take this click to move the any device. Just you should click on that and click the left mouse and move. Can move. This is the positive. Delete and reconnect it. If any mistakes are, just say for example if you want to delete it, just click it and delete, it will go. Okay. I'll connect this wire here. Okay. Now what we have to do, what we did now, from positive to, it is a main millimeter. Okay, let's call current flowing through this millimeter as what, say it is a, let's call this as A1. It is ammeter 1. It should be in ampere range because all these meters should be ammeters now. Let's call this as A2. Again, this should be in ampere range. And this also, let's call it as A3. And this also in ampere range. Now, this is A1, this is A2, and this is A3. Now, what we have done, we have connected the positive to the first of the first millimeter, then negative to the one end of these two registers, which let's call this is R1, okay, and R2. Let's give the name for this. This is R1, okay. both by default it will be 1 kilo ohm. Let it be the same. Later we can change those values. So let's call this as R2. R2. Okay. And let's connect. What we have to do now, we have to connect these both the negatives of the millimeters to the power supply, the negative terminal. This also should go there only. Otherwise, from here to here also we can connect it. Anything is fine. Both are the same. I'll do it here. Not a problem. Okay. Just I'll use, this is the positive. Just red I'll use of the millimeter, and this is not mandatory. Can use any colors, not a problem. And this is let's use it as black, and this is also black. Just to click on that, it will show its parameters and change these accordingly. Okay. If you click on this, so it will show some random voltage. By default will be the 5. Let's make it as say 2 volts. Okay. Now no coding here, directly go for the simulation. You can see now is a 2 volts. The total, the resistance, of course these two are in the parallel now. Okay. When we connect the two resistors of equal resistors in parallel, the resistance will be the half. So it is equivalent to connecting the 5, it is a 500 ohm, it is 1 kilo ohm. Okay, 1 kilo ohm, 1 kilo ohm. If you connect them in parallel, it will be exactly half of that. So the current will be what, 4 milliampere. So 2 volts divided by 500 ohm, in the mid 4 milliampere. So since both the resistors are same, okay, it equally divides 2 milliampere in one resistor and 2 milliampere in other resistor. I can use another resistor also here, okay, in the main circuit. So I'll try to stop the simulation. I will connect one more resistor here. Just you click on the wire and delete it. Okay, take a resistor. So in the beginning, you take the same resistor, and you, in the left side top corner, there is one rotation tab will be there. Just you click on that. Okay, so it rotates in a single direction, so it won't go in reverse direction. Okay, so just to connect wire to this, make it red, and this is fine. So now go for the simulation. So it will be less now, because 2 volts only, power supply is 2 volts, but now the resistance in the circuit is what, this is 1 kilo ohm. All these are 1 kilo ohm only now. 1 kilo ohm plus this 500 is 1.5 kilo ohm. So 2 volts by 1.5 kilo ohm, if you calculate, it will be around 1.33 milliampere. So that's going to divide equally here. Okay, 0.66 milliampere. This is 0.6 milliampere. Okay. Now you can linearly, you can rotate this. Just you click on this knob, so keep on rotating in the right side, as we do in the lab in our RPS. So there is a change. So at any moment, if you see the readings, let's call this is I1, and this is I2, and this is I3. Okay, so if you add these two, that must be is equal to this, so that you can observe there. Okay, if you want to set a particular voltage for the RPS, if you rotate this, it won't be exactly like 2 volts, 4 volts, 6 volts like this. So it may vary either more or less. So I want to set this for 10 volts. Just to click on this RPS and go to the voltage range, remove it and type 10. So it is what, 10 volts. So So this is the 10 volts now. This is in main circuit, it is a 6.67 milliampere, and in both the branches, it is equally will divide. It is a 3.3 and 3.33 milliampere. Hope you understood this circuit. So we can use the KCL in the same way. We can do KVL also. With the circuit, the KVL is easy to connect also. Just you use the resistor, rotate it. Okay, and if you want the similar, just you click on this, copy it, Control C, and paste Control V. So you'll get another resistor. And Control V, so get another resistor. So let's use 3 registers. Okay, and take a power supply. KVL circuit is easy to build. Take an RPS, or connect a wire from here. Just join these 2 registers. Join this and connect this to the negative of the power supply. Okay. For our convenience, let's from the positive, let's use the red wire, and here this is the black wire. So here maybe black or red in other location, doesn't matter. Now we have to do use the 3 voltmeters. Okay, take a multimeter here, just you 1 multimeter. Click on this multimeter, Control C, copy it and paste it here only. Otherwise, you can take it from the list also. Control V, and 1 more. Control. Okay. Now we have to connect. This is the positive side of the power supply. So this side, it is the higher potential. So when this is single path is there, current is the same. Okay, but the voltage drop depends on the value of the resistor. In this case, in the first time, we are going to use all our 1 kilo ohm only. The voltage drop will be equally. So later we try to change the values and see the simulation. Now let's connect the wirings for the multimeters. This side should be positive, and this side is what? The negative. Okay, and again the same. For each resistor, I'm going to connect a voltmeter. Okay, here also the same. So you can fine. Now we have to use all these as the voltmeters. So just click on this. So it will be what? Let's call it as V1. This is a V1, and this is a voltage range should be there all. Let's call it as V2. So V2, and this is a V3. Okay, and let's call it as the register. This is R1. Let's call it as R1. So resistance, let it be 1 kilo ohm only now for first time. Click on this register, call it as R2, and this is R3. Now the connections are over now. Click on the power supply. So by default, it will be 5 volts. Let's set it for say 3 volts. So why I'm taking 3 volts? Because 3 volts equally will divide because the ratios are the same. So 1 volt, 1 volt, 1 volt should be there when I start the simulation. Okay. So this is simulation. You can see now the 1000 millivolts. this is 3 volts, this 1000 millivolts, 1000 millivolts, 1000 millivolts. If you convert them into the volts, it's nothing but 1 volt, 1 volt, 1 volt, because the resistors are same. If the resistor values are different, the voltage is also different. Now I'll change this voltage as what, say 6 volt. If it is 6 volt, the voltage drop again will be the equally, that is 2 volts, 2 volts, 2 volts. Okay. Now I'll change the resistance value. Let it be 1 kilo ohm. Okay. Let's make it as 2 kilo ohm. I'll make it as 2 kilo ohm. You can see. This is let's make it as 3 kilo ohm. See, this is 1 volt, this is 2 volt, this is 3 volt. Because as the resistance value increases, the voltage drop across the individual resistors also will increase. So this is 1 volt, this is 2 volts, this is 3 volts. If you add up all these, again it will be the same power supply voltage. So I'll need not be all in kilo ohms. I'll make it as, say, 100 ohm. This is, it shows 100 kilo ohm. Let's make it as 100 ohm. Okay, you can see. So this is 100 ohm. This is 2 kilo ohm. This is 3 kilo ohm. Okay. So now this is very small voltage. That is a 0.18 volts. It is a 118 millivolts. It is. If you convert into voltage, is what 0.18 millivolts. This is 2.35 volts, and this is 3.53. If you add up all these, so it will be approximately 6 volt. So 5.99 something. So in the same way, in the lab also we'll get the same readings and all. So this acts like the very good virtual lab. Okay. So we can do the experiments and show to the students. We can write a Tableau column also. We can write these readings also. It will be the same. So especially in such situation, there is COVID-like situation. So all the students and the teachers are at home. Okay. But we are doing the online classes, but what about the lab and all? So this is the way to do certain labs. Of course, it is difficult to design certain experiments and all, but it is possible to design and practice few experiments.
Dr. Maltesh. Dr. Maltesh.
Sir, namaste.
I am doing it simultaneously. I did it.
Wonderful, sir. Thank you. Thank you so much. I suggested for many participants also, if they have the laptop and all, that will be easy. If it is not there, just they can go through the concepts. Later they can do it. I told the same thing for that. So here also the many participants are practicing it, sir.
Yes, very nice, sir. It's good. So good moment.
Yes, sir. Thank you, sir. Thank you so much. And even Arduino also, I had sent the link also to download the software Arduino IDE in their laptops and the systems if possible, so that they can practice simultaneously. That's also possible.
Okay, that's
yes,
nice.
Yes, thank you. Thank you.
Yes, sir.
Hello, sir. Maltesh, sir.
Sir, namaste.
For the first time, I'm seeing that.
Sir, tell me, sir.
Okay. Like this, we can do even in op-amp also. We can teach op-amp and all that.
Yes, sir. Certain circuits are there, sir. We can do that.
Okay. Even filters and all that.
Yes, yes, yes. Okay. So we have the capacitors and resistors are there. So that is enough to build the filters and high pass and low pass filter. That is enough.
Low pass. Okay.
Yes, sir. Yes, sir. Thank you.
I think it is very easy to understand that is what, especially
yes,
the heat exam and all that.
Yes, sir.
The different combination very easy that.
Yes, sir. Yes, sir.
Thank you.
M.N. Baswaraj, sir.
Yes, sir.
This is the professor from the Kanakpura College, Professor Krishna Patyapur. He is
sir, good evening, sir.
Sir.
I have seen him. He is a good friend of mine.
Yes, sir. Yes.
Yeah.
I have met him in a workshop, in a refresher course in the physics.
Sir, he is sir. He is a Krishna Patyapur, sir. He is one of the guide to me also. So I have learned most of the things from sir.
Oh, yeah, no, sir.
Yes, yes. Please don't use the annotation there.
Sir, operational amplifier is available.
Yes,
okay,
right.
Sir.
Yes, sir.
Yes.
Yes. Thank you. Thank you, sir.
You can do that also.
I'll continue, sir.
Yeah,
yes, sir. Please continue.
Yes, thank you. Thank you so much. Please don't use the annotation there. Remove it, please. don't write anything on the screen, please. So once you finish the simulation, just you click on this, go to the home page. Yeah. So I was talking about the characteristics of the diode. So already the circuit is there. Just I'll use that. So this is the diode characteristics. Okay. So if you already designed in the circuit, it will show like this. Just to click on the tinker this. Okay. So as I said, it will be a bit slow working online. Yeah, fine. So well, now I'll go for the start circuit. I think you know in the same way how I build the other circuits. In the same way you can build this. You can observe now the diode is in the forward bias. So already most of us know. I told in the beginning also. This is the P type. This is the silver ring. That ring is N type. Okay. The P type is connected to the power supply, the positive terminal through this path. That is through the resistor and the millimeter. Okay, and this is a N type. N type is connected to the negative terminal of the power supply. So this is what the forward bias we call it as. So if P type is connected to positive and N type is connected to negative, we call forward bias. So when the diode is forward bias, it starts conducting, but not immediately. When the forward bias, that is the voltage across the diode, is more than the new voltage. Okay, that is a 0.7 volt for silicon, 0.3 volt for germanium diode. Now we'll go for the simulation. Okay, you can observe now. Just I'll change the voltage, just like 0.1 I'll do. So we have to change. Usually in the diode characteristics, we'll start with the small voltage. So it is what the 200 millivolts in the power supply. There is 0.2 volts. So the current is 0. As I said, if the diode is silicon, unless and until 0.7 volts. So it means it starts conducting from 0.5 or 0.6 something. But the current becomes can start to increase for a small change in the voltage in a large way only after the new voltage. Okay, now I'll change this to a bit another voltage. So I'll make it as it's showing 0.4 volts. That is a 400 millivolts is nothing but 0.4 volts. This 0.4 volts will drop across the resistor as well as this diode. So you can observe now it is a 0.399 or 399 millivolts. In volts is what 0.399 volts. So current is 0 again. So now we go for little higher voltage. 0.4 I do almost same. I'll change again. Sorry, by mistake I clicked on this knob, so it is increased now. I'll make it as 0.5. Okay, so it's showing 0.6 in the power supply now. So you can observe now. There is a small current is there. Actually 733 microampere. If you convert into milliampere, 0.733 milliampere. Very small current. What is the voltage now? Voltage across the voltage in the power supply is what? It is a 0.6 volts. But out of this 0.6, small voltage will drop across the resistor as well as the diode also. So only the voltage across the diode we are going to consider now. So 0.527 volts. It is a 527 millivolts. If you convert into volts, it is what? 0.527 volts. So the current is very small. So now I'll change the voltage. 0. The higher voltage I'll go. Okay. 0.6 it is same. 0.7 I'll do. 0.7. So This is 0.75 will do. You can see for us now onwards, I'll change only the second digit of the after 0.7. So, but there is an increase in the small voltage across the diode, but there
Sir,
will
you
be
can connect
large.
one more voltmeter also now here, sir.
Sir.
Sir, if you connect the one more voltmeter across the resistance,
Yes, sir. We can do,
so
sir.
that whatever the excess voltage will be there, it will drop
Yes, sir.
across
Yes,
the
yes, sir.
that
Yes, sir.
we can do it.
Yes, like in the previous circuit in KVL, Kirchhoff's voltage law, we did. I had connected. In the same way, we can connect it, sir. That both the sum of the two voltages will be the power supply. If you want, I'll connect it, sir. Now, not a call. So just to click on this, let's call this some voltage. This is a V2. We can call it as. Yes, the positive this side. Just I'll drag this to right side. Nothing will happen. So the wires will not be connected at all. The negative terminal on the other side. Yes, sir. Fine. So I'll go for the simulation now. You can see this is 0.8 volts in the power supply now. Okay, it's a 0.8 the volts. You can see now 0.24 volts and 0.558. So if I add it up these two, this is a 0.558 volts. This is 0.242 volts. Approximately it is a 0.8 volts. So this is the current through that. Okay. So another 5 minutes are left now to 7 because I got the feedback that the many of the students and participants have joined some other sessions also, and some other people will have some assignments and all after 7 o'clock. So I have a request to finish before 7. So I started a bit early. From next time, if possible, I can start at 5:30 itself, and we'll wind up at 7 o'clock. So 3 more minutes are there. If any questions on this now, on today's session, so we can ask on this now.
Here, how do you define that the diode is germanium or silicon?
Sorry, sir.
Hello.
Sir.
Sir, will you define this diode as a germanium or silicon in the circuit?
Sir, only in this circuit is only silicon is given. This is the diode. Yeah, silicon. Germanium is not given. So depending on
because yeah,
yes,
nowadays all silicon diodes are available in the market.
Yes, sir. Yes, sir. Yes, sir.
Oh, thank you, sir. Good.
Thank you, sir. Any other questions from the audience? We'll meet again tomorrow at 5:45. 5:30 is, I think, for few people will be the early. Let's meet at 5:45 tomorrow till 7 o'clock. Any questions, please? Here is a question in the chat box. Sir, how to join in Tinkercad? I'm not able to. Okay. I'll do one thing now. Just on the right side. Usually, how we log in the Gmail. Usually, right side our the profile picture will be there. Just to click on this now. I'll stop this simulation. Click on this. Right. Go to the home page first. You can log out. See, I'll log out now here. And I'll log out from Google also. Yeah. Still, I'll go back. So this is the Chrome screen. Okay, any browser you can go. So just you type here, or here also you can type. No, it doesn't matter. Tinkercad. Okay. So you click on this. This screen will be available. You can see here. So join ins, join now, or sign up and all. So sign in you can give. Okay. So sign in with Google. So that is easy for us. Okay. So it asks any of your Gmail ID. So I'll give my Gmail ID. So type the password. It takes, as I said, it takes a little bit amount of time. That's very simple. We'll reach our home screen. So here you can see left side 3D designs, circuits, and all will be there. Just to click on the circuits. So here, so whatever the circuits we have already designed will be available. Recently used circuits will be the first, and other circuits will later. Now to design the new circuit, just you click on this create new circuit. So it will open the new page. The left side, the blank page will be there, and right side the components will be there. So you can select any of these components and build the circuit. I'll see a few questions. Sir, what are the uses of the Ohm's law? I think the participant might be from the computer science or some other non-electronics something. These Ohm's law states that what it is going to be used to analyze the circuits. Ohm's law, Kirchhoff's laws. There is KVL and Kirchhoff's KCL, Kirchhoff's current law and Kirchhoff's voltage law and the Ohm's law. These are called the basic laws in the physics circuits or the electronic circuits. So these are going to be used to analyze the circuit. That is circuit analysis. The meaning of the circuit analysis in the sense how much amount of the current is going to flow, how much voltage is going to drop in a particular branch of the circuits. To identify these, we use these Ohm's law, Kirchhoff's laws and all. Okay. The next question is basically to determine the voltage and the current. Okay. Someone has answered it, I guess. Thank you. Nice question. If you have, don't mind, the question may be either small or big, it doesn't matter. The clarification is the important for us. Thanks for asking such questions. Yes, the network is slow. So it is not like a network is not slow. Whenever you start the working on the Tinkercad, so it will be very slow because it has to work here and it has to communicate to the others and all. So usually it looks a bit slow here. Any questions? Okay. Thank you so much. It's already 7:03 now. So let's meet tomorrow by 5:45. Thank you, Professor M.N. Basaraj, sir, who is the principal of the SGRC Degree College. And thank you, Krishna, sir. And thanks to all the participants for joining. Happy evening. Be at home and be safe. Thank you. Thank you so much.
Thank you.
Yeah.